Have you ever looked at a math problem like 4x minus 7 equals 2x plus 9 and felt a little lost? It might seem complicated, like a secret code that only mathematicians can understand. But, I want to let you in on a little secret. It's not a secret code at all. An equation is simply a puzzle, a kind of mystery waiting to be solved. And the unknown, that little letter x, is the missing piece you're looking for. Finding its value is the key to making the whole puzzle make sense. These puzzles aren't just for math class. They are the building blocks for understanding the world around us. From calculating the speed of a car to figuring out a budget. They help us find unknown quantities in science, engineering, everyday life. Our mission today is straightforward and achievable. In the next few minutes, we're going to demystify this process completely. We will break down the task of solving for x into a series of small, manageable steps. Think of it like a recipe. If you follow each instruction in the right order, you're guaranteed to get a delicious result every time. By the end of this guide, you won't be guessing anymore. You will have a reliable method, a mental toolkit that allows you to approach these problems with confidence and precision. Before we jump into the steps, let's make sure we understand the fundamental goal. An equation is a statement of equality. That little equal sign is the most important symbol in the entire expression. It is a promise that the stuff on the left side has the exact same value as the stuff on the right side. Our job is to find the unknown value, usually represented by x, that makes this promise true. Think of a classic balancing scale. If the scale is perfectly balanced, the weight on both sides is identical. An equation works the same way. The left side and the right side are in perfect harmony. The golden rule of solving equations is this. Whatever you do to one side, you must do the exact same thing to the other side. This is the principle of maintaining balance. Add 5 pounds to the left side, the scale tips. Add 5 pounds to the right side, it balances again. The same logic applies to math. If you add a number, subtract a number, multiply by a number, divide by a number. Before you start moving things across the equal sign, the very first step is to clean up. Think of it like tidying your workspace before you begin a project. Your goal in this step is to make each side of the equation as simple and compact as possible. This means you are not working across the equal sign yet. You are only working on the left side by itself, and then on the right side by itself. Look at each expression and see if there is any arithmetic you can do to shorten it. This initial housekeeping makes all the subsequent steps much easier and less prone to error. The main task here is to combine like terms. Like terms are pieces of the equation that are of the same kind. For example, terms with an x in them, like 3x, like 5x, are like terms. Plain numbers without any variable, which we call constants, like plus 7, minus 2, are also like terms. You can add or subtract them from each other. So, if you saw an expression like 3x plus 7 plus 5x, you would combine the 3x and 5x to get 8x. The expression would simplify to 8x plus 7. Now that both sides of our equation are neat and tidy, it's time to start organizing. The goal is variable terms, the x terms, on one side, and constant terms, the plain numbers, on the other side. Think of it like sorting laundry. Socks, shirts. Convention, variables usually go left. We'll do that for consistency. Step 2. Move all variable terms to one side. Example, 7x minus 8 equals 16. Here, 7x is already on the left, so nothing to do. Example, 5x minus 3 equals 2x plus 9. We have variables on both sides. Gather them left by eliminating 2x on the right. Use the opposite operation. Since 2x is positive, subtract 2x from both sides. Move 2x from right to left. Negative 2x appears on both sides. So we get 5x minus 2, x minus 3, equals 2x minus 2x plus 9, which simplifies to 3x minus 3 equals 9. Step 3. Move constants to the other side. In our example, 3x minus 3 equals 9. The variable term 3x is on the left. We want to get it by itself. so we need to move the minus 3. Opposite operation. Add 3 to both sides. Move minus 3 to the right. Plus 3 appears on both sides. This looks like 3x minus 3 plus 3 equals 9 plus 3. This simplifies to 3x equals 12. Look at what we've accomplished. We started with a jumbled equation, 5x minus 3 equals 2x plus 9. And by systematically applying these two steps, we have transformed it into the much simpler 3x equals 12. All the variables are on the left, and all the constants are on the right. This process of isolating terms is the heart of solving equations. We are on the home stretch. After simplifying and sorting, you'll typically be left with an equation that looks something like 3x equals 12, negative 5x equals 20. The variable x is almost by itself, but it's still attached to a number. This number, the one multiplied by the variable, is called the coefficient. Our final step in finding x is to undo this last operation, which is almost always multiplication, division. The goal is to get the x completely alone, to isolate it, so we can finally see its value. It's like, unwrapping the final layer of a gift. Let's continue with our example. 3x equals 12. When you see a number right next to a variable like 3x, it implies multiplication. To undo this multiplication, we must use its opposite operation, division. 3x divided by 3 equals 12 divided by 3. On the left, 3 divided by 3 is 1, leaving us with just one x, or simply x. On the right, 12 divided by 3 is 4. So we arrive at our final answer, x equals 4. What if the variable is being divided? To undo this division, we use its opposite, multiplication. Our solution is x equals 10. This step is critical. Be careful with signs. Now that you're comfortable with the basic process, let's try a slightly more challenging problem. These problems aren't actually harder, they just require a little more care, especially with negative signs and fractions. Don't be intimidated. The steps are exactly the same. The rules don't change. We just need to be more deliberate with our calculations. Let's solve this equation. 1 2x 3 solves 7. This puzzle includes both a fraction and a negative number, making it a great test of our method. Our first action is step 1. Simplify both sides. Looking at the left side, 1/2 x minus 3, we have a variable term and a constant term. They are not like terms, so we cannot combine them. The left side is already simplified. The right side is just negative 7, which is also as simple as it gets. We can proceed to the next phase of our plan, which is to start organizing the terms across the equal sign. Next, we execute steps 2 and 3. Step 2 is to gather variable terms. The opposite of subtracting 3 is adding 3. Our equation is now 1/2 x equals negative 4. Another way to think of 1/2 x is x divided by 2. To undo multiplying by 1/2, or dividing by 2, we need to do the opposite, multiply by 2. On the left, the 1/2 and the times 2 cancel each other out, leaving just x. On the right, negative 4 times 2 is negative 8. Our solution is x equals negative 8. Let's check it. Plug negative 8 back into the original equation. 1/2 of negative 8 is negative 4. So, negative 4 minus 3 equals negative 7. This simplifies to negative 7 equals negative 7. It works. The most frequent mistake, by far, is forgetting the golden rule. Doing an operation on one side of the equation, but forgetting to do it on the other. To combat this, always write down your work for every single step. Another major area for errors involves negative signs. A third common pitfall is incorrect distribution. When you see 5x3, multiply the 5 by every term inside the parentheses. Theory is great, but the only way to truly master a skill is to practice it. You have learned the rules, you have seen the examples, you are aware of the common pitfalls. Now it is your turn to be the detective and solve some puzzles. Here are your 5 practice problems. 1. Solve for x. X plus 6 equals 13. 2. Solve for x. 5x equals 20. 3. Solve for x. 2x minus 4 equals 10. 4. Solve for x. Negative 3x plus 2 equals 11. 5. Solve for x. 1/3 x equals 5. Now the answers: 1. X equals 7. 2. X equals 4. 3. X equals 7. 4. X equals negative 3. 5. X equals 15. How did you do? If you got them all right, congratulations, you did it. If you made a mistake on one or two, don't worry at all. That's part of learning.